Yes, Assalamu alaikum everyone. So in the last class, we have discussed all the factors which can affect the equilibrium position, and then we have discussed that how from certain data we are able to predict whether the forward reaction is exothermic or endothermic, and we have discussed all those factors. Now we are going to move towards the equilibrium expression. So what is equilibrium expression? Basically, equilibrium expression is also called equilibrium constant expressions. And these are actually helps us to, these are actually uses to express the ratio between the products and the reactants uh, at equilibrium. Okay, so these are also called equilibrium constant expressions. Okay, so what they usually do, it links the equilibrium concentration of products and reactants with equilibrium constant at equilibrium. So all the things we discuss, sorry, yeah, with equilibrium constant at equilibrium. So when we take the ratio of the reactants and the products, we call that ratio as equilibrium constant. Okay, so there are two types of equilibrium constants. First, we will discuss the equilibrium constant Kc. Okay, so what does Kc refers to? So K is refers to equilibrium constant, but over here when we are using the term C, so remember that this C refers to concentrations at equilibrium. It means the values of the concentrations that we are using over here, these are the concentrations at equilibrium. Is this clear to all of you? Yes, Nail and Ahmed?
जी sir.
Okay.
Yes.
Now, further, what we do, we use square brackets. And what is the purpose of a square bracket? Yes, does anyone know? To express the concentration of any reactant or product. So instead of writing the whole, statement that the react concentration of hydrochloric acid, instead of writing this whole thing, what we do, we just, write, put the square bracket and enclose HCl in it. So it means that the concentration of hydrochloric acid. So instead of writing the whole term, we just write the HCl and enclose it in the square bracket. So concentration of any reactant or product in Kc expression. So the Kc expression, examiner asks you to write the Kc expression for 1 mark. 1 mark is for determining the unit for the Kc expression, and further marks are related to solving the numericals based on it. Is this clear? Okay. So, for example, if I'm writing HCl in the square bracket, so it means that I'm saying concentration of hydrochloric acid. So it's up to me. I write the concentration of hydrochloric acid. Instead of writing whole this, I represent this with this. When I am writing the mathematical expression for Kc, I just include it, the formula in the square bracket, which means concentration of that substance. Is this clear?
Yes, sir.
Yes, Ahmad.
Yes, sir.
Okay. Now the next thing is writing Kc expression. So how we will write the Kc expression? Let's see. For example, I have a one reactant A and the other reactant B turning into a product C and another product D. Okay. Now, if I try to balance this equation, we usually use the numbers, but right now instead of using the numbers, I'm just putting the small letters M, N, P, Q. So these two are the reactants. These two are the formulas of the products. Till here, is this clear to all of you? Okay. And the M, N, P, and Q are number of moles in balanced equation. So I assume those number of moles as M, N, P, and Q. Yes, is this clear to all of you? So now if I'm going to write the Kc expression, so the Kc expression is actually going to be equals to concentration of the C raised to the power P, which is its number of moles, times concentration of the second product, which is D, raised to the power Q, which is its number of moles. So it's easy to remember that you need to put the concentrations raised to the power of the number of moles in the balanced equation for the products in the numerator, and these are multiplying with each other. So it is product. So on numerator, it is the product of the concentrations of products. We are taking their products over concentrations of reactants. So concentration of A raised to the power M times concentration of B raised to the power N. So that is how we write the Kc expression. Is this understandable?
Ji, sir.
Yes, Ahmed. Is this clear to you as well?
तो इसके क्वेश्चन मोल के साथ आ सकते हैं?
Yeah, I'm just giving the format. Now we are going to try the equations. For example, let's assume we have hydrogen gas reacting with bromine gas, and let's assume over here we got the reversible grid, and over here we get HBr. So if I balance this equation, as there are 2 and 2, so I need to put 2 over here. So if I make the Kc expression out of this, so it is going to be concentration of HBr square upon concentration of hydrogen times concentration of iodine. Yeah. Oh, yeah. Br. Is this clear? So
Ji, sir, समझ गए.
that's how it works. Yes, Ahmed, is this clear to you as well?
जी
Okay. So I'm working for one equation and driving the unit. Then I will have three more equations that what I want you guys to do. That three. So the first equation, I have a hydrogen gas reacting with iodine gas, forming 2 moles of hydrogen iodide. If I go for a Kc expression, so Kc expression is going to be, as we have discussed, concentration of hydrogen iodide raised to the power 2, because there are 2 moles in the balanced equation, over concentration of hydrogen times concentration of iodine, and there will be no power over here because it's 1, because there are 1 moles in the balanced equation. Is this clear?
Yes, sir.
Okay. So what I did, I just write, I just wrote the Kc expression. Now I'm going to work for the unit. So as we have discussed that the square bracket is representing the concentration. So what is the unit for concentration? Yes, what is the unit of concentration?
मोल पर डेसीमीटर क्यूब.
Mole per decimeter cube. So in the numerator, we have a mole per decimeter cube. And it's a square in the equation. So I put the power 2. In the denominator, I have a concentration of hydrogen times concentration of iodine. So it means, again, I have mole per dm cube for hydrogen and times mole per dm cube for iodine. So if I solve it, what I will get? Mole per dm cube whole square in the numerator, and in the denominator, it again goes, as both are mole per dm cube, so it also goes mole per dm cube square. So these two are going to be cancelled out, and we have no unit for Kc specifically for this reaction. For every reaction, the Kc has a different unit value, and we need to drive every time. Is this clear?
Yes, sir.
Yes, Nail. Oh, yes, Ahmed.
जी सर.
Okay. Now part 2. We have a nitrogen reacting with hydrogen, forming ammonia gas. Yes, how to balance this equation?
3/2 to H2.
And if we have to balance in our whole numbers,
H2 2.
वहां पे 2 लगाते हैं, वहां पे 3 लगा.
so before NH3, we are going to put,
कुछ भी होता
yeah,
है.
2
3.
and 3. So now I want you guys to write the Kc expression and then drive the unit. Okay. So do it and WhatsApp me quickly, Nail and Ahmed.
Okay.
Yes, Nail and Ahmed.
तो
Yep.
बस आपको 1
मैं
मिनट में
आपको
व्हाट्सएप
दिखा
कर रहा हूँ।
देगा।
Yep.
Okay.
Okay, I got from Ahmed.
ये सिर्फ ये थोड़ी देना है
Where is the unit, Ahmed?
और इसमें पहले 2 मिनट में पूरा कर दिया
तो यूनिट 7 लिखना है।
That you have to do it like this as I did in on the screen. You can see the yellow working and then drive it. Because they ask you a unit for separately for 1 mark.
तो मतलब वैल्यूज से कुछ लेना देना नहीं है,
No.
सिर्फ
You
सिर्फ
have
यूनिट से करना है।
you had to drive the unit like you
अच्छा,
did.
हर जगह डलेगा तो मोल पर डेसीमीटर क्यूब ही ना,
Yep, because it's concentration.
और उसको हम इंडाइसिस के रूल के हिसाब से पावर वगैरह से कर लेंगे।
Yes.
सही।
Okay, so Nile, very good. Unit is good. And the KC expression is also good.
सर ये H23 नहीं होगा?
Yes. Okay, so the expression will be the concentration of ammonia square over concentration of nitrogen times concentration of hydrogen cube. And on deriving the unit, we got mole inverse square dm raised to the power 6. Is this clear?
Yes, sir.
Okay, now third equation. Sulfur dioxide gas reacts with oxygen, forming sulfur trioxide gas. Okay. And to balance this equation, we need to put 2 and 2 before sulfur dioxide and sulfur trioxide. The equation got balanced. And now, yes, if I write the KC expression, Ahmad, tell me. Yes.
क्या बताऊं फिर?
Okay, wait, you will explain me the unit. 9. What I put in the numerator?
So 2SO3, SO3 brackets में और 2 ऊपर
SO3 in the square bracket and 2 goes
and
to
2
the power because we put the products on the numerator, and in the denominator there are
SO,
2 reactants, so we put 2 square brackets.
yes.
In one square bracket, we put SO2 and its power goes 2 because there are 2 moles of that. And in the second bracket, we put O2 with power, we keep it 1 because there are 1 moles. Okay. Now, yes, Ahmed, tell me how.
न्यूमरेटर
Yeah,
पहले मोल पर डेसीमीटर क्यूब लिखेंगे टू द पावर ऑफ 2
mole per dm
और
cube square. Yes.
नीचे से एक बार वापस मोल पर डेसीमीटर क्यूब टू द पावर ऑफ 2 और एक बार टू द पावर ऑफ 1 मतलब कुछ भी लिखेंगे.
Yes, and the mole per dm cube. Okay. So we got the two same. So we just cancel them. And when we move the one which is left to the numerator, it will become mole inverse
1 इनवर्स और +3
and dm cube. I hope it's understandable. Okay. So let's last the trickier one. So I'm telling you it's a trickier one. So let's see who will do it correctly. So now you need to write the Kc expression and grab the units and WhatsApp me. Okay, so you are going to do it here, Mariam.
इलेक्ट्रॉन्स की एडिशन कर सकते हैं.
No,
जरूरत नहीं है.
the rule is simple. If there is a coefficient, that become power. Beside the coefficient, the rest of the thing is actual formula. So you need to keep it in the square bracket. That's it. But what I know that 99.9% students write this equation wrong. Yep. There is a little, the normal, everything is normal, but there is a one.
Oxidation number
No, there is nothing to do with the oxidation number. That is the formula. So you just keep it as it is and put it in the square bracket. And if there is some coefficient, you need to put it as a power. That's it.
Sir, Ag solid.
Yes, very good.
Sir?
Then I'll.
Ag solid.
Yes.
Ag solid तो नहीं आएगा ना केसी में.
Why?
So I guess pure solids and pure liquids तो नहीं आते इस reaction में.
Why? The question is why.
तो ये नहीं याद आ रहा, मुझे ये पता है नहीं होता.
What does square bracket represents?
concentration.
Concentration. And what is concentration? How can you define a concentration?
If it's for an aqueous.
Number of moles of solute in a solution. So if something is solid, how it is a part of a solution?
जो बात है sir.
So it's not the part of the solution. That's why we can't put it there. So when you are writing the Kc expression, Ag solid would not be included in it because it's a solid. It's not dissolved in the solution. So there is no concentration for Ag. So from product, we have only Fe3 plus ions, which are actually aqueous. And their power goes 1 only because the coefficient is 1. Yes, Ahmed, did you understand this?
जी सर, मैं समझ गया था।
Good. These are apparently looks it's two. So the unit derived is mole inverse dm cube. Is this clear to all of you?
Yes, sir.
Yes, Ahmad.
जी जी सर।
Okay. So here is a point related to this. If the chemical equation contains substances in the aqueous state, then we rewrite only those substances in the Kc expression, which are in aqueous only, and we ignore all of them. But for example, in some reactions, we are forming with the aqueous substance, we are getting water. So water is a liquid, but that water we are able to calculate. So that's why we include that water in the Kc expression as well. Okay. But if there is no substance in the aqueous state, then Kc expression, we just put the substances which are in the gaseous states only, because you can see over here, these all are gases, and we make their concentrations in these three cases. So, but we got the aqueous. So if in the equation there is an aqueous substance, so we keep only aqueous substances in the equation and nothing else. But if there is a water, we can put the water. For example, if you look at this one. So in this, they haven't mentioned the state symbols, and the reason is the same, that sometimes the student got confused. So because in actual, if you look, so what you will find, that is aqueous, the alcohol is aqueous, the ester formed is aqueous, and that is liquid. But we are able to calculate this amount of water, that how much amount of water is formed, because the ratio of these two are exactly 1:1. So this, the amount, the number of moles of ester formed, the water formed would have a same amount. So that can be calculatable. So that's why we usually keep that water in the Kc expression. So over here, what will be the Kc expression? That we have a one reactant CH3, oh sorry, one product CH3CO2R, which is ester. So concentration of ester times concentration of water over concentration of ethanoic acid CH3CO2H times concentration of an alcohol ROH. So R is the carbon chain, we don't know. Now over here they are asking for the unit. So if you see, you can easily predict from the Kc expression there will be no unit, because you have mole per dm cube, right, as the concentration of ester. So that is same will be the concentration of water mole per dm cube. Then for ethanoic acid, this would be same mole per dm cube, and then mole per dm cube. So all going to be cancelled from each other, and we will get no unit. Is this clear?
Yes, sir.
Okay, so see, 2 marks, 1 mark for the writing the expression and 1 mark for the unit. Okay. Now I got one question for you guys to attempt. So NO is also found when nitrosyl chloride dissociates according to the following equation. And here we got the equation that 2 moles of NaCl is decomposing into 2 moles of NO and 1 mole of chlorine. Different amounts of 3 gases were placed in a closed container and allowed to come to the equilibrium at 230 degrees Celsius. And then the experiment was repeated at 465 degrees Celsius. The equilibrium concentrations of the three gases at each temperature is given in the table below. So let me tell you, this question is the most easiest question for KC. Okay. This is the most easiest question for KC. So in the first part, what they are asking you to write the KC expression. So if I go over KC expression, so KC is equals to, you have equation on the top. You got the concentration of NO square times concentration of chlorine divided by concentration of NOCl nitrosyl chloride raised to the power 2. And give the units. See, they have asked you the two things, KC and give the unit. So if you see, we have a square in the numerator and we have a square of concentration in the denominator. So those would cancelled out and we are left with one concentration of chlorine in the numerator, right? Because the unit of this and this would, these two are going to be cancelled out, mole per dm cube square and mole per dm cube square. So we are just left with mole per dm cube. Yes, till here is this clear?
Yes, sir.
Okay, now in the next part, they are asking you to calculate the Kc value at 230 degrees Celsius and at
465.
465.
Yes, sir.
Yeah, so at 230 degrees Celsius and see over here, the equilibrium concentration. So you know the equilibrium concentration at 230 and you know the equilibrium concentration at 465. So that's why I told you initially that this is the most easiest one because they have given you the concentrations at equilibrium and you need to put it in the Kc expression. So if I put it over here, so Kc is equals to, for 230, the value of NO is 1.46 exponent minus 3 square times the concentration of chlorine is 1.15 exponent minus 2 over the concentration of nitrosyl chloride NOCl is 2.33 exponent minus 3, but I need to put the square. Yes, who will tell me the answer?
तो मेरा कैलकुलेटर फायर हो गया, बस 1 सेकंड में दूसरा वाला ला रहा हूँ।
Five to the power minus 3.
4.515. Okay. So 4.515, and if I need to put it in the three significant figures, so it is going to be 4.52, 10 raised to the power minus 3. So that is the value for Kc at 230 degrees Celsius. Now if I calculate the value of Kc at 465 degrees Celsius, so the concentration of NO is 7.63 exponent minus 3. Yep, square times 2.14 exponent minus 4 over 3.68 exponent minus 4 square. So we are getting 0.127, so 0.0913.
तो 0.091
0.0913.
0.0919.
19 कैसे होगा?
0.010917. That is the value in the calculator, and 72 and so on.
वैसे मेरे पास तो 0.091995 आ रहा है.
Okay, so it means it is going to be 0.1920.
0.0920.
Yeah, so when we round it off to three significant figures, it will go 0.0920. Okay. So see, you have calculated this. Now see, this whole thing, these three parts are for 5 marks. These. And yeah, these are really free marks. So who is going to answer me the last part? Is forward reaction endothermic or exothermic? Explain your answer. So first you need to predict whether it's forward is exothermic or endothermic. Yeah, you have the data. We increase the temperature. We perform the reaction at two different temperatures. Now you need to figure out from the data that whether the forward reaction is exothermic or endothermic. Okay, so first recall, if a reaction is reversible, on increasing temperature, where the equilibrium position shifts?
To the right.
No. Endothermic side, and we need to figure out whether the endothermic side is backward or forward, right? So remember, increases in temperature shifts equilibrium towards endothermic side, and now we have to look for the side, which side is endothermic, the forward or backward. Is this clear?
Yes.
And it means when we lowers the temperature, equilibrium shifts towards the exothermic side, and we need to look for the reaction, whether forward reaction is exothermic or the backward reaction is exothermic. Okay, now if you see, if you look at Kc expression, so Kc, and what are these? These are the products. These are the concentrations of product, right? So isn't it Kc is directly proportional to the concentrations of the products? Yes? Yes, Nail and Ahmed, is this understandable?
Ji sir.
Okay,
Yes.
so it means if the Kc increases, it means there are more product. And if the Kc value is lower, then it means there is lesser product. So if you compare these two values, at which temperature we had a greater Kc value? Yes.
460.
465 has a greater Kc value than the Kc value at 230, right? So it means that when we increase the temperature, we got more product. It means on increasing temperature, forward reaction occur, which helps us to figure out that the forward reaction is endothermic, because we know the rule that on increasing the temperature, equilibrium shift towards the endothermic side. Is this understandable now?
Yes sir.
So you are going to write that it is endothermic, and they are asking to explain. So what will be the explanation? As Kc value is higher at higher temperature. So which means more product is formed at higher temperature. It means that the forward reaction is endothermic. That's why increasing temperature results in formation of a more product. Is this clear?
Yes sir.
Okay. Now, the next two questions which I'm going to discuss here. Hey, कौन भागा? Okay, my internet. Okay. So here we go. So I'm writing the equation over here. And what in the information that we got so far, that 2 moles of NaCl is reacting or is actually decomposing to give you NO2, 2 moles of NO2 and chlorine. Actually, it's NO, not NO2. Yep. 2 moles of NO and chlorine.
Yes.
All are gases. And what we got further, that the delta H is positive, which means that the forward reaction is endo and the backward reaction is exo. That's what we have concluded in the last part. Now, so these are the questions which the things we discussed in the last class. So they are asking about those factors. If we change it, if there is some change in one of them, then how the the equilibrium position shifts and what happens.
LHS को ज्यादा फेवर करेगा क्योंकि वहाँ पे गैस मोल कम है.
Okay, 1 minute. The temperature of the equilibrium was then altered so that the equilibrium concentration of NaCl and NO were same as each other. Okay. What will be the effect on equilibrium concentration of NaCl when the following changes are carried out on this new equilibrium? In each case, explain your answer. So what they are saying, that they have maintained a equilibrium in such a way where these two got the same concentrations at equilibrium. Okay, the pressure of the system is halved at constant temperature. Yes, what we did, we lowers the pressure, right? The pressure of the system is halved at constant temperature. So what we did, the pressure is decreased. So when we decrease the pressure, where the equilibrium shifts?
More moles of gas, lesser moles of gas.
Just decide, we are decreasing the pressure, equilibrium shifts towards the more moles of gas or less moles of gas.
नहीं राइट साइड पे जाएगा, ज्यादा मोल्स है उधर.
Yeah, towards more moles, because when we decrease the pressure, we actually expand the area. So the thing is that they are going to turn into more moles to restore the equilibrium. So equilibrium shifts to the right. And what happens to the concentration of NaCl then?
Decreases.
Yeah, because they have asked you to effect on equilibrium concentration of NaCl. So equilibrium concentration of NaCl decreases as equilibrium position shifts to right as right hand side has more moles of gases. Is this clear to all of you? Yes, now you were disconnected. Just go through this answer and tell me if you have any query related to this.
Okay, sir.
And till then, Ahmed and Mariam, think for part 2, that the mixture of NaCl gas and NO gas containing equal number of moles of each gas is introduced into a container at constant temperature. Just think, don't answer me. We will discuss it. Yes, Nile, are you done with part D1?
जी सर, समझ आ गया.
Okay. Yes. Ahmad, what will be the answer for D2? What is the answer for D2?
वापस राइट हैंड साइड को फेवर करेगा।
Why?
नहीं, लेकिन इस तरह राइट हैंड साइड की कंसंट्रेशन तो आइदर वे अभी भी ज्यादा ही है, मोल ज्यादा ही है, तो क्या पता लेफ्ट हैंड साइड पे जाए।
This is the new situation. This is not related to anything from this. This
सर
is
वही बोल रहा हूँ,
from this
मिक्सचर है ये, तो
condition.
NOCl और NO इंडिपेंडेंट ही नहीं रहे।
See, initially they have told you that equilibrium is established where the concentration of these two gets equal. They have maintained the
यस
equilibrium in such a way. And then the mixture of Na and NO containing equal number of moles of each gas is introduced. So you got the equal moles of these two again. So both sides are actually getting greater moles, but with the same factor, with the same ratio, isn't it?
यस
So it means there will be no effect either on the position of equilibrium and no effect on the concentration of NOCl. But you are not sure.
मैंने कहा था नो इफेक्ट आपने स्ट्रक्चर एक ही बनाई मिलेगी मैंने तो कहा था कि सेम नंबर ऑफ मोल्स है वो कैसे इफेक्ट करेगी
So because both sides already has the same number of moles and you are introducing the same number of moles of both the things again. So it will not affect the equilibrium position and the equilibrium concentration. So the equilibrium concentration of NOCl and position of equilibrium does not affect. And why? As both sides are increased by same number of moles. So if only one side is increased with the number of moles, or if both sides are increased with the different number of moles, then obviously the equilibrium position would shift to the any side or either side to minimize that change. But right now, as both sides are increased by the same number of moles of gases, so it will not able to shift the position or not the concentration of NOCl. They both remain same. Is this clear?
Yes, sir.
Okay. Now I have one question for you. This is a higher order question. Now, who is going to attempt it and tell me the idea how to do this? Yes, Mariam. Yes, Ahmad. Yes.
यार इन सबका AR पता करना पड़ेगा हमें।
Okay. So here we go, ethanoic acid. There are two carbons, which makes it 24, 6 hydrogens,
2 carbons?
2 oxygen,
Oh yeah, okay, 2 carbons.
and 12 and 2 oxygens, so 32. So 32 and 24, 56. 56 and 6. Is it? No.
56 and 6.
No, there are 4 hydrogens, so it is going to be 60. So 60. So if I need to calculate the moles of ethanoic acid, so it is going to be 6.0 over 60, which makes it 0.1. Is this understandable?
Yeah.
Now you got 6 grams of ethanol. So if I work on the formula or MR of ethanol, so 24 plus 6, which is 30, plus 16, which is 46. So 6.0 over 46 is 0.8. I don't know. 0.13. Okay, so 0.13 moles. So over here we got 0.10 moles. Was added to 4.4 gram of ethyl ethanoate, and the overall mixture is allowed to reach equilibrium. So this is ethyl ethanoate. Okay, so 60 plus 46 is 106. 106 minus 18, 88. So that will be the MR of ethyl ethanoate. So 6.0, no, sorry, 4.4 over 88 gives you 0.05. Is this clear? Okay. So see, if you read the question carefully, what it is stating that a mixture of 6 gram of ethanoic acid, 6 gram of ethanol was added to 4.4 gram of ethyl ethanoate. So it means, isn't it, these are the initial values or the initial modes of all of them, because see, these are allowed to mix with each other, isn't it? These were the which were mixed, and the overall mixture is allowed to reach equilibrium. Then after these have been mixed, then the equilibrium has been established. It was found that 0.04 moles of ethanoic acid was present in equilibrium mixture. So it means these are the moles at equilibrium, and these are the moles at equilibrium of ethanoic acid only. What they are asking and what is their requirement? Calculate the number of moles of each compound both initially and at equilibrium. Okay, so remember, okay, now I'll just quickly go through this. What they gave you that you have a 6 gram of ethanoic acid, you have 6 gram of ethanol, and you have 4.4 gram of ethyl ethanoate. You mix all of them, and then you allowed to reach the reaction to establish an equilibrium. So it means that these masses which are allowed to react are the initial amounts. So from these initial amounts, we got the initial moles. Is this clear? Yes, Ahmad and Nail?
जी सर सही है.
Yes, Mariam, is this clear? Okay. Now, 0.04 moles of ethanoic acid was present in equilibrium mixture. So it means these are the moles at equilibrium mixture, and that is for ethanoic acid. And now they are asking to calculate the number of moles of each compound, both initially and at equilibrium. So initially we have already calculated, but for equilibrium, I need to calculate. So remember, whenever you need to calculate the amount of any substance at equilibrium, what you will need to do, you always go for ice table. What you need to do, you will draw ice table, and if you follow the ice table, the steps of ice table, then you will able to calculate or get the amounts of substance at equilibrium. Okay, so what does ice table stands for? That's what we have discussed in the last class as well. It is initial change and equilibrium. So over here, if I draw the ice table, I have a I over here, C over here, and E needs to be in the middle. Oh, sorry, my bad. C in the middle, the change, and E is over here. So if you see, that is the amount of ethanoic acid I calculated, and this is initial. So I'm going to put it in the raw of I, 0.10. I have calculated the initial amount of ethanol as well, which is 0.13. I have calculated the initial amount of ethyl ethanoate as well, which is 0.05. And water has 0. Okay, so I'm just putting the arrow over here just to that you guys don't ignore the difference that on the left side we have the reactants and on the right side we have the products. Okay, so if you look at one reactant whose initial amount is also there and final amount is also there at equilibrium. So if you see initially it is 0.0, it's just 0.10, but when the equilibrium has been established, it goes 0.04. So it means it is used up because it is just 0.1 and now it is 0.04. So it means how much of this has been used up?
0.09.
So it means 0.06 moles of this has been used up. So over here, I'm going to mention the change in the negative form because this amount has been reacted, the 0.06 has been reacted and turned into the product. That's why the leftover amount of at equilibrium is 0.04. This is the amount at equilibrium. So it means this is the amount of ethanoic acid which is left, which is unreacted at the equilibrium. But when they are mixed, how much it's 0.1. So how much of this has been used up? If you subtract it from this, you will get the amount which has been used. 0.06. It's 0.1 and it is 0.04. So it means this is the amount of ethanoic acid which has been used. So that's why I put the negative sign over here, which indicates that this is the amount which actually turned into the product. Is this clear to all of you?
Yes, sir.
Okay. So if you look at the ratio of both of them, what is their ratio? 1:1. So it means if ethanoic acid has been used is 0.06. So the amount of ethanol that also has been used must be 0.06. So if you subtract it from the initial amount, you will got 0.07 as the number of moles at equilibrium. Is this clear?
Yes, sir.
So we got the moles of ethanoic acid at equilibrium. They are given to us. We got the moles of ethanol at equilibrium, which are 0.07. Okay. Now, why I put the arrows in the middle over here? So you guys must remember that if these are being used up, so these over here, this amount is going to be add up because these are the product and their ratio is again 1:1. So if the ratio is 1:1, so the same amount is going to be added over here. So on the product side, the change is going to be positive with the same value because the mole ratio is 1:1. So ester becomes 0.011 at equilibrium and water becomes 0.06 at equilibrium. Is this clear? Oh, yeah, sorry, 0.11. Yes, so we got the amounts in moles at equilibrium. Is this clear? 4 marks for all this. Okay, now calculate the Kc equilibrium constant for this reaction. Now we know the concentrations at Kc, the moles at Kc. I'm going to put it in the Kc expression. So Kc is equals to, we know the Kc expression that it is going to be CH3, CO2, C2H5 to the power 1 times concentration of water. Yep, over concentration of ethanoic acid raised to the power 1 times concentration of ethanol to the power 1. Yep, so there will be no unit. Okay, now again, and another thing, what are these values? These are the values at equilibrium, but which quantities are these? These are the moles. And over here, what we need to put, but we are not going to put concentrations because the volume actually got cancelled. If you have no concentration in this equation, you can just go with the moles as well. Because whatever the volume, you are going to put that volume, like if it's like, let's suppose it's 2 dm cube. So you are going to put 2 dm cube with all of them over the moles, right? So these 2 and 2 get cancelled and you are just left with these moles. So you can just calculate with the moles without turning into the concentration. And that's why if you read the question again, they haven't given you the volume. So you just need these values. So it is going to be 0.11 times 0.06 divided by 0.04 times 0.07. So the Kc value is going to be,
सर सॉरी वो आवाज नहीं आ रही थी, आप ये बता सकते हैं कि हम इनको पावर की तरह से नहीं लिखा?
can you repeat again? Yes, Ahmed.
ये आवाज कट गई थी, आप ये बता सकते हैं इनको पावर की तरह से नहीं लिखा?
Power.
ये जो मोल्स हैं
What can you just
पावर की तरह से नहीं लिखा?
Because these are the moles which are present in the equilibrium mixture. These are not the moles which are used over here to balance the equation, right? The equation is already balanced with the 1 mole of each of them. That's why I didn't put any power over here. Is this clear, Ahmed?
सही सही समझ गया.
So these are the moles at equilibrium, and what I have discussed, I didn't convert it into the concentration. The reason behind this is, for example, let's suppose the equilibrium mixture has a volume of 0.5 dm cube. So I need to multiply, divide it with 0.5, divided with 0.5, divided with 0.5, and divided with 0.5 in order to convert into the concentration. So all the volumes get cancelled. So again, I am left with these values. So that's why I directly use the moles instead of using the concentrations. Okay, now in the last part, they are asking you to calculate Kc in this reaction has no unit. Why? But why?
मोल मल्टीप्लाई हो रहा है concentration.
Units, no unit, because these were cancelled out as reactants and products have equal number of moles. So that's why the unit gets cancelled. Is this clear? Any confusion so far? So remember this rule. Okay, so if amount at equilibrium is not provided, then you need to do I stable, where I stands for initial, C stands for concentration, E stands for equilibrium. Is this clear to all of you?
Yeah.
Okay, so we are keeping the class till here, and I have one homework question for you guys. Yes. And if you guys
ग्रुप पे
want to have a more class, then we can do like on Tuesday after Taraweeh, the online one, but not physical. Okay, so here you go. This is the homework. You can take the screenshot, Ahmed, and share in the group. Okay, share in the group that this is the homework. Okay, then see you everyone in the next class. Take care. Goodbye.